Hey guys, welcome to Master and Learn It. This is our second segment of differentiation by standard results. There is a technique that we can apply. Instead of doing differentiation from the first principle, we can differentiate from the standard results. So I'm just going to touch a little bit from differentiation from the first principles so that you can just catch up from where we have left. Suppose you have a curve that says y is equals to x squared. So we said if you want to calculate the gradient here using the first principle, you are just going to come and write this. This is the first step that I normally do, not to confuse myself. I'm going to have my x1 and my x2 is going to be x plus h. That's the basic thing that you have to do first. Then from this you need to apply your rule. In this case the rule they are saying square it. So if you square it, you're gonna get your y1. So this is my y1. So if I take this x, I square it, I'm gonna get x squared, which is my y1. For me to get my y2 here, I'm going to take this expression, I apply the rule, I square it, I get x plus h squared. So this is the y2, this is the y1, x2, x1. Then we just substitute. So if I want to calculate the gradient from here, I'm going to have y2, that's x plus h squared, minus y1, which is x squared, all over y, x2 being, x2 being x plus h, minus x1, which is just x. So if we simplify from here, clearing brackets here, we get x squared plus 2xh plus h squared minus x squared, all over x minus x, that's 0, we're left with h. X squared subtract x squared, that's 0, we're left with 2x h plus h squared, all over h. Then now since we want to set the limit, remember we said we should be writing when the limit h tends to 0. Let me just write it when the limit h tends to 0, when the limit h tends to 0, when the limit h tends to 0. Then at this point I have to take out one h so that I can factor out the h there. Dividing h will cancel with this h, I'm left with 2x. H will cancel. How many h's here? There are 2. It's like h times h, that's h squared. So I'm gonna cancel with this h. H cancels h, you are left with 1h. So h cancels this, I'm left with 1h, all over my denominator h. Therefore h cancels with h. We are on the limit when h tends to 0. So now I have the expression 2x plus h. Now I can finally substitute when h is 0. So we are going to have 2x plus 0, which is just 2x. Remember, this is our gradient from the first principle, but there is a technique that we can apply straightforward to get the gradient 2x without having to go all this long way. So basically, you need to listen to the question. If a question says differentiate from the first principles, apply this. But if the question just say differentiate, you have to use the standard results, which is the lesson that we are about to learn. So the next segment says differentiation by standard results. This is much straightforward and not time consuming. Suppose you have your function y is equals to x squared. If I say differentiate this, you are going to say exponent, we can call it an exponent or an index. You're gonna say exponent times coefficient minus exponent. That's straightforward. What we're simply saying is, remember, we have a coefficient of 1 right here. So what I'm going to do is I'm going to say the exponent times the coefficient 1. So 2 times the coefficient of 1 remains 2. Then I have my x. Then we say minus the exponent. I have you must say minus 1 rather, not. So we are going to say exponent times coefficient minus 1. So here what we're going to do, exponent times the coefficient 1, we get 2x to the power of 2 minus 1. So we get 2x, 2 minus 1, that's 1. Do you realize that this is the 2x that we found from differentiation from the first principle? So this is straightforward. So let us just try to look for another example. Suppose you are given a situation that says y is equals to 3x to the power of 4 minus 3x squared plus 2x. Then you're asked to differentiate this. This could be time consuming if you were using differentiation from the first principles. But by using standard results, we're gonna differentiate term by term by term. So here I'm going to say, if you are given an equation that says y, so we use dy by dx. That means the gradient function. Exponent times coefficient, that's 4 times 3, that's 12. X to the power of 4 minus 1. Minus, then from here, exponent times coefficient, 2 times 3, we have negative 6x to the power of 2 minus 1. Then we have positive exponent 1 times 2, which is 2x to the power of, there is a 1, minus 1. We can simplify this to be dy by dx is equal to 12x, 4 minus 1, that's 3, negative 6x, 2 minus 1, that's 1. Then here we have 2. Remember, 1 minus 1, that's 0. Any number to the power of 0 is 1. So we have 2 times 1, which just still remains 2. So this would have been our gradient function. So there are a few basic principles that we should just know. We should know that if you say differentiate y is equals to 4x squared plus 3 plus 3, same principle, dy by dx is equal to exponent times coefficient, 2 times 4, that's 8x to the power of 2 minus 1. Then differentiation of a constant, it's 0. There is no x. This is a constant. So differentiating a constant is 0. Why? The reason being, if a constant, it just means the gradient is constant. It's 0. There is no gradient right there. So the final answer right here is going to be 8x 2 minus 1, which is 1. That will be the gradient function. So when you are asked to differentiate by standard results, you should know that dy by dx of a constant is 0. That's what we should know. Then we should know that if we have a that's the basic thing. You should know that differentiation of a constant is always going to give you 0. So if the question is silent, doesn't say use differentiation from the first principles, just use differentiation from the standard results. That's pretty much simple. Just once again, suppose I have a function that says f of x is equals to 2x squared plus 4x plus 1. So differentiating this, since the function here is written in the function f of x, I'm not going to say dy because there is no y here, but I'm going to write the derivative this is how you are going to write your derivative. The derivative of this function would be exponent times coefficient, 2 times 2, that's 4x to the power of 2 minus 1. Differentiating here, same applies. Coefficient exponent 1 times 4, that's 4x to the power of, there was a 1 here, minus 1. Then differentiation of a constant is 0. So final answer, the derivative is equal to 4x, 2 minus 1, that's 1. There's a prefix, there's a hidden 1 here, plus 4, 1 minus 1, that's 0. Any number to the power of 0 is always 1. So 4 times 1 remains 4. Differentiation of a constant is 0. This would have been your derivative. I hope this video was beneficial. If you don't understand anything, please just drop a comment, and always don't forget to subscribe to Master and Learn It. Watch us in the next video.